in the room, of course, and there will be an opening for me, and then that's very nice. We have our director, Rinke who will give a speech on a keynote about Alliander digitization and open source. Afterwards, we have also a nice use case presentation from Demetris from TU Delft about his PhD research and application of Power Query model. We have a short coffee break. Afterwards, we have someone remote from Francesca from Italy to present the integration of Power Query model into their multi-energy semantic platform. I suppose, Francesca, are you already online?
Yes, I'm here.
Welcome. Afterwards, in this session, we plan 2 parallel sessions to make also the meetup a bit more customized for both the experienced user and the beginners. And so here we can have the brainstorm on new features, presentation of highlights, and brainstorm on the new feature request. At this other side, we will also announce later is that there is a second table which my colleague will also present, give a short demo to the people who are new to this model, so you can actually get your hands dirty on how this model will look like. Afterwards, we will have a closing, and then of course there will be drinks and networking for people who are physically here. So without further delay, I will give the floor to Rinke.
Yeah. Thanks. And I noticed that you were probably not visible on the camera, Tony, in your introduction. So maybe if we can, will this work if you turn it around? Yeah. So people online can see me as well. Hello, everybody. Great to speak, to talk to some of you. Welcome for some new people at Alliander, and also for all of our guests, face-to-face, and other companies I heard, other partners. So great. And welcome, thanks for having me, Tony. You planned this a while ago, so yes, my agenda worked this time. Yoo-hoo. Great, well, happy to be here. I'm Rinke van der Rhee, Chief Digital Officer at Alliander, or in Dutch, Directeur Digitization. I lead IT, OT, operational technology, and also all of our digital programs. So I'm a big fan and supporter of what we're doing over here. Tony asked me to explain a bit about our challenge, our strategy, our digitization strategy, and also why we think open source is very important as part of that strategy. So that's my 25 minutes. So Tony, if you can do time management for me, because the topic is so much fun that I tend to take a bit more time. Okay, this is probably the one. Yeah, there we go. So outside in. What's our challenge right now? Well, it's not a big surprise, I think, as a company. And you, as a lot of people who know a lot about the sector, maybe more than I do with specific topics. Our challenge is the second energy transition. And so the change from fossil fuel-based society, economy, etc., to a society based on renewables. Big change. And as a matter of fact, for us, as a Dutch grid company or a distribution system operators, we tend to call ourselves, it's actually the biggest challenge in the history of our company. So we have a history of about 100 years. And everything is changing. Our processes, balancing supply, demand, storage of electricity. So a lot going on. And why do we call it the second energy transition at Alliander? Well, because the first one already took place. Frank here, I know Frank a long time. He's laughing because I use this picture. Sorry for everybody who already knows this picture. I like one of my hobbies is history. This is also part of Alliander. This is Amsterdam, end of the 18th century. And actually, this is what we're trying to get back to. Yeah, that's an interesting concept, because this is local renewable energy sources, locally produced, locally consumed. And if the city expanded, they just tore down the mills and built them up at the new parameters of the city. Yeah, so, but yeah, there was no Alliander, no grid company, and no central production of power back then. So we didn't have all the issues that we have right now. But well, maybe a brief joke, but some history. If I get a chance to put some history in my presentation, I will. We'll look into the future as well, of course. Now, what this challenge, the energy transition, looks like. and it's going in a really fast pace right now. Here are some figures, but what actually this sheet shows, or this picture shows, is that we have multiple trends that accelerate and strengthen each other. So if you look at, for instance, well, what's happening right now in Ukraine, or what started more than a year ago, we see, as an effect, we see a lot of companies and households switching from natural gas to electricity sources. It could even be the bakery around the corner in the village that wants to quit with natural gas. There's a lot of electric mobility going on, heat pumps in the homes, etc. So all these trends go into the direction of peak demand, or big peak demand. So big change. And you see also the charts that we make with our algorithms. Remember the charts? We're not proud of them because red and orange and yellow is not the corporate color of the Alliander brand. Yeah, sure.
Is your microphone on?
Can everybody online hear me?
Yes, I can.
Yes.
Okay. Oh, we have two microphones. That's interesting.
No,
Thanks,
the handheld microphone
yeah.
is not working.
Yeah, it is working?
The handheld microphone is not working.
Oh, okay. So I can skip. Can everybody hear me without it? Processor. Okay. We'll do dual processing. That works. Okay. So these colors, I said, that's not just branding from the marketing department. No, it's because we have problems by getting everybody connected to the grid, by providing capacity, grid capacity for everybody that wants to use the grid. So it's actually going on right now. Our issues around the energy transition. And just to make it very small, this is another challenge we have in the energy transition. This is a picture of Amsterdam, protesting citizens, or customers, I should say, in Amsterdam. Because alone in Amsterdam, we need to double the complete energy infrastructure by 2026. It's just two, huh? And then we have to, I think going towards 2036, we have to triple the energy infrastructure. This is cables, this is substations, this is secondary substations, everything. But if we try to do it, then we run into this, because everybody wants to have PV, everybody wants to drive an electric car and have solar panels on their roof, but they don't want to have a small electrical asset in front of their house. So that's another challenge here we have. So now let's get down to strategy. If we look at this energy transition, we think digitization is a crucial enabler. And if you look at the different parts of our strategy and digitization, we come down to three important things. First of all, with this digitization, we're trying to increase our operational output. Just be more productive, help our engineers, get more cables in the ground. So that's what we use, for instance, digitization for. Another important thing is to prevent unnecessary work. So if we can influence the energy system, if we can make sure that, for instance, wind power and solar power is tuned in the right way, or we can bring supply and demand together at the right place at the right moment, then we can prevent work, or we can prevent unnecessary work. It's another thing where we use digitization for. And the last part is better utilization of the grid. The trends I explained before are all leading to peak demand, but peak demand is not always there, not 24 hours. So where can we make better use of the existing grid? And balance, or use flex, or we have all these fancy names right now, congestion, flex, etc., to manage that. That's all about better utilization of the grid through digital smart solutions. And if you take a step back and look at the energy system, then there's this picture on the right here. I'd like to use that where we explain it. This is part of our energy vision 2050 or 2030 or both. So you can look that up if you want online. But the future energy system, we see that in order to manage, to deliver these services that I explained on these three strategies, we need to provide new digital services to the Dutch society and to partners, contractors, etc. And these digital services are being offered and supplied by system operators or market operators. They in turn need energy data on assets, consumption, smart metering data, etc. And this is all provided by a digital layer that connects the physical grid. The physical grid here on the bottom, electricity grids, hydrogen grids or heat grids, etc. And also storage and conversion. But we need to connect that by a digital layer to these system and market operators. For instance, provide services to balance charging electric cars in an area or whatever. There are multiple services and smart services that we well, this digital layer helps us to make better use of the grid, to provide optimization services in this grid. If we do that in the right digital way, I think here's exactly where the topic that we're talking about today fits in this right here right a red area. The red is good in this time. Yeah, so here you see, for instance, the power grid model in the middle, or at least from my perspective, as being very important to connect the two together. But if we do that in the right way, we provide a digital layer on our physical energy system, a digital layer that is limitless scalable, and then we can use here at Alliander in Delft, but worldwide as well. Because for an algorithm or this model, the algorithm doesn't care where the cable is, where it's in the ground. And that's how we like to think in the past. And we thought about physical assets and where they are, but as soon as you digitize things, you can scale endlessly everywhere like you want. So we call this digital layer, this concept, actually the digital distribution systems operator. We used to be a non-digital grid company. But now we talk about the system because we have to balance consumption, production, and storage. And digital is, well, what I explained, we provide this digital layer. We also have a vision to go with that. It's a bit older, this one, but it's still pretty good, I guess. We made this one with some of the stakeholders that are really into what we are doing still right now at the Linux Energy Foundation. Well, we made a picture, I think this was 7-8 years ago or something, or maybe even longer. We had a lot of digital visions on the specific functions we had to perform as a grid company. And then somebody came with the bright idea to say, hey, if you combine all these different pictures, what does the future look like? And then we made this. We called it Alliander Virtual Grid. And this actually explains, and there's a story behind this as well, but I don't have time for that right now. But this explains how we look at the autonomous future energy grid, or future energy system, I should say. Why do I show this picture? Because if I look at what we're doing right now with the Energy Foundation and other things, I see that we fill in a lot of the functions that we put in this picture. That's really great to see. Back then it was a far ahead future. Right now, 8-9 years later, we are really delivering on this future, and it's accelerating as well. You'll probably see that again in the rest of the afternoon. Well, what we need is actually 3 things. We need better software. Hey, we think open source. Well, we're not the only one that thinks open source can help us get better software. Not everything we do is open source, but we tend to really like our open source software. We also did a lot of quality checks, etc., and it looks really good. So we need better software to do this, to do this strategy. We also need a faster time to market. Years ago, companies like us were just talking about working efficiently, so not spending too much money of the society, about quality. We still think a lot about quality. But right now, the discussion with me and with the other grid companies, especially also in the Netherlands, is about time to market. Everything right now is about time to market. How can we work faster? Well, also there, I think open source is a real good opportunity and a real good solution to speed up what we are doing. And that's also because we want to use the power of the crowd. And that works in multiple ways. If we can work in an open source way, we can use much more brains, of course, and have a lot more fun my way as well. But I don't have to explain that to you. You all know that, I guess. What we also found out is that people who work on open source are proud of what they produce. And if you program something in whatever SAP or something, nobody will see it. Or you have to look deep down into maybe into the notes. But of course, if you work in open source, then it's obvious that you can show to everybody what you have done. And so open source is also for us a strategy to tie into the workforce and the bright professionals globally. So that's another way, a reason why we do open source. How am I doing, Tony? We need to ramp up. Okay. Open source at Alliander. Well, we already work quite some time with open source. I'm not running through that, but some of the brands and some of the products we use, and the technologies we use, and with that we follow the European Commission guidelines on open source. That's been there a while. I think this is 20. Oh, I don't know. Anyway, we like to look a bit at the EU regulation, being a semi-regulated company, a group company, Alliander. And more interesting, I think, also for this afternoon, that I'm really happy that we joined the Energy Foundation. And I looked at the Energy Foundation website again. I just talked about that with some of you. It's going so fast. You cannot make a sheet. Well, this is of course all technology. Yeah? It's not real time. I should present this from a real time base, but it's going so fast. As strategic partners, I think it's much more already. Yeah? It's a lot of, and if you look at the members, it's sort of exploding, which I think is great. Also, if you look at the projects, these are the projects I think I know a bit about, and that we work with. And I know some of them because in the past we used to work on open source communities also within Alliander, and we try to find out what is that, creating an open source community like smart society serves and things like that. But we incorporated this knowledge and this coding and everything in these models into these projects. So I know a bit about those. But when I looked this morning again, it's like, wow, there's so much going on. It's really, really, really great. So, and of course, there's Power Grid model. That's sort of a very brief one for you. So just to wrap up, Alliander, big challenge, energy transition, like most of the participants in this sector. We use digitization to be smarter and to manage partly the energy transition. Working to an autonomous electricity or energy grid somehow. So we're working back to the 18th century, sort of. And we think open source is a key enabler to do that. To get time to market, to use the crowd, etc. So that's why I think we're a big supporter, and I'm a big supporter of what we're doing here right now. That was sort of what I prepared. Maybe some Q&A, or not sure how we look at the time, Tony?
We have another 10 minutes. So we have
wow. Oh, usually I make it longer. Okay. Any questions? Or we're ahead of schedule and can get coffee. Yeah.
Do you know if any other institutions already joined the Power Grid model and they're developing it together, or?
I think that's a question I have to pass to my colleagues.
I think, good question, but then I think we can go in depth. I think we can go in depth to that in the session after the coffee break. So we can have more in depth on that. Any more questions?
So we'll.
Thank you. Maybe Tony, you can repeat the question.
Yeah. We have two mics going on here. Yeah.
You can.
So when you make an open source model of code, how do you check with the EU regulation?
Mm-hmm.
How do you do that?
Good question. I actually have to ask my colleague of mission control, who's about quality. But maybe some other colleagues can help me as well. I do, and you probably can give a better answer. But we do have an OSPO going on. Yeah, that's probably what you're going to say, right? Yeah. Oh, so let me please answer the question. Yeah, sure.
Microphone. So the question is how we meet with the regulations part of open source. So at Alliander, we also have an open source program office, and we aim at 3 things at the open source program office. One is to get better in control using open source, and that's partly getting more in control about compliance. So how can we make sure we comply with the open source license, which can be tricky because of many of licenses. Secondly, also important, and we will work closely with both the Compliance and the Security Act, with CISO and Mission Control, also get better in control of the open source risk aspect. Open source software is not more secure than proprietary software or less secure, but similar with proprietary software, as open source software, you have to take the security aspect into account. So that's also one of the things we now closely work with Mission Control and CISO to get that more on the radars. So that is two examples we work on. Of course, there's a broader trend in Europe, but also at the Dutch government. I'm happy to see that our Ministry of Internal Affairs also decided to start an OSPO this year. They're kind of building on to also stimulate European collaborations, both on the European level but also global level. And open source is seen more and more also from a regulatory perspective as one of the means for that, which is also actively pushed by the European Commission. So if you're interested, you should look up the Horizon program from the European Commission. So that's a really big investment program from the European Commission, where they really stimulate or even mandatory act for people who want to participate in these calls. They have to make their solutions open source available so that everyone in the European community can use it, but also outside the community. And also future research can continue on those projects. So there's a lot of regulated push as well. Of course, it goes in slow steps. So if you ask me, I wish it goes faster. We definitely see moving more, and I expect in the upcoming 5 to 10 years it will only increase, both from the power sector, but also from the public sector as well.
Yeah.
So this answers your question.
Yeah, thank you. Much better answer than I could have.
So any other questions?
Maybe people from online? No, then I have a question for Rinke.
Oh, Tony knows me very well.
We have a lot of collaborations on open source with other research institutes and DSOs and grid operators, governmental bodies. I wonder what's your vision on Alliander's collaboration with open source project with actually commercial parties like Face2Face or other commercial parties who are aiming also for profit?
Tricky question. It's being recorded, the session, isn't it?
Yeah.
Okay, I'll just check it. Yeah. I think it's. I look at this in a positive way. So I think if you look at the challenge that we are facing, I just called energy transition. It's the easiest way. We need everything and everyone that can help. And that could be providing open source. That could be putting a market mechanism in place to accelerate something or to achieve our goals faster. I think it's fine. I do think that the core should be open source, so including the core models. And what I would expect is that other participants will build value-add services onto that core. So for us, the most important topic is energy system integration. So if open source, also in terms of models, but also in data models, etc. And this is power grid models, of course, much more complicated just the data models I know. But everything, I think that the integration part, so the various components, being technical, economical, that should be able to integrate and collaborate in the energy system. I think that should all be open source or free for everybody. But if people want to build services on that, that's fine. That's exactly what we do to manage the energy system. If we have capacity in the grid at a certain moment, or a peak, or I should say, if we have a peak in demand or supply, and we try to put that on the market, put a price on it, and let market participants help us manage that congestion or manage that. So we have a lot of examples where market mechanisms can help us. But I think the basis, I call it integration, but it's a very broad concept of integration. I think that should be open for everybody. Yeah, I hope you think.
Any more questions? Also for online? No? Yeah?
What are your
on integrating open source software with
That was the same question. Okay, great. Okay. Yeah. Okay. Yeah. Yeah.
Okay. In that case,
Yeah.
I would thank Rinke for coming here.
Yeah.
I hope to also see you later in the.
I hope to drop by later on. I have some other obligations, unfortunately. Yeah.
So yeah.
Thanks for having me. Have a
Yeah.
look.
I'll cover the same thing that you have said. Also, the question is how do we cope with security and support? I think this is the question Jonas already answered, and for the people who are interested in our general Alliander open source strategy, I think Jonas, you can contact them.
Yeah. So reach out to us at ospo@alliander.com if you have any questions on the deep dive. One of those.
Thank you. And then we would like to invite Demetris from TU Delft to give our first exciting presentation. Wow.
Maybe this one.
Better to stand in. People can hear you better.
Yep. Hello. This is my presentation on distribution network aggregated flexibility estimation. First, an introduction about me. I am a PhD candidate at TU Delft, and my PhD is part of the Megamind project, where Alliander is also a member. My education includes a bachelor's degree in electrical engineering and a master's in robotic systems and control. So the motivation for my research is that in the past, system operators had to deal with passive consumers, so they knew their patterns and they could easily predict their operating conditions. However, in the current state, as distributed generation increases and as active users are increasing, there is high variability and unpredictability in the networks. And this increases the disruptions that the networks face, and also the costs that the system operators have to suffer. And for this reason, we're aiming to provide new methods to the system operators, which can reduce these costs and disruptions that the networks suffer. And my main focus is on flexibility estimation in distribution networks. So the outlook for the presentation starts with what is flexibility, then some state-of-the-art methods, then deep dive into the computational burden issue, and then the final part on the observability issues for the problem. So starting with what is flexibility, I should start with explaining that this flexibility is the aggregated one. So it's the total flexibility that can be offered at the point of common coupling. Just one pointer. So we're talking about the flexibility that can be offered at the point of common coupling, connecting TSOs and DSOs. And it's the flexibility coming from flexibility service providers within the distribution network, such as load or generation or battery energy storage systems. And this estimation, starting from an operating condition of active and reactive power at the point of common coupling, the task is to find all reachable conditions when shifting the output of these flexibility service providers. For example, in this figure, the orange part shows, starting from this operating condition, if we shift some flexibility service providers, we can reach this new active and reactive power. And reaching this is feasible through certain actions. On the other hand, these infeasible positions mean that the offers might exist, so flexibility service providers might exist that can shift their output to change the point of common coupling PNQ to reach here. But the network constraints might not make this shift feasible or this combination feasible. Therefore, yeah, this is an infeasible shift. So the state-of-the-art methods towards estimating this flexibility area are mainly split into the iterative power flow-based approaches and the iterative optimal power flow-based approaches. These two methods have their positives and their negatives, but also have some limitations that both of these approaches suffer, that I will go into a bit more detail later. However, now I will go into detail about each individual method and their positives and negatives. So starting with the optimal power flow-based approach, this approach says that starting from this operating point, as shown previously, we have four main objectives, which are to maximize the active power from the TSO to the DSO, to maximize the reactive power from the TSO to the DSO, and to minimize those values as well. However, if we see those four objectives alone, it is clear that the first and the third and the second and the fourth cannot be combined together because they are the exact opposite. Therefore, there can be four possible combinations of these objectives, which are the squares shown here. And by choosing each of the combination, the algorithms which use optimal power flows are trying to find the flexibility area within these squares. However, still the issue is how can you combine two objectives in a single optimization function? And the main approaches applied in academia are the weighted sum, the constraint, or the radial reconstruction. For the sake of brevity, I only introduce here the radial reconstruction, which says that instead of having two objectives to optimize simultaneously, we can say that we will optimize a single objective, let's say the active power, and then we will say that the reactive power should always be along a gradient theta. Through this, the objective function will try to maximize the shift starting from the operating point towards a certain angle and a certain direction. And through this, in one iteration, the algorithm will return this value, for example. In the next iteration, it will reach another value. And by the end, the algorithm will try to find the convex hull covered by all these points. Issue with these algorithms can be that they cannot deal with discrete variables and they need to linearize them, but also they cannot deal with discontinuous areas. For example, starting from an operating point here, such algorithms would predict flexibility area shown with the red area behind. But in reality, if applied the discontinuous shifts, the area should be discontinuous. Besides this, there is also a bit of high computational burden applying these algorithms, but still, these algorithms are faster than power flow-based approaches. Now, the power flow-based approaches are quite simpler than the previous, where starting from the initial operating point, they simply take random shifts that are feasible from different service providers. They apply those shifts and run a power flow and check whether the power flow was feasible or not. If the power flow is feasible, this new operating point is considered as feasible, and then they go to the next operating point. However, such approaches will need thousands and if not millions of power flows run, which, no, not million, but towards 100,000 power flows to run, which will make it quite slow using some libraries. In addition, another difficulty for these algorithms is how to decide which sampling distributions from the flexibility service providers. And also is that for each additional flexibility service provider that is included in the algorithm, the sampling space increases. However, since we can notice that the power flow based approaches have main issue being the number of power flows need to run and the computational burden, it's where we saw that the power grid model can improve this issue and can offer a good solution. So we have this algorithm, or we created this algorithm that a user can give input a scenario with all the information they need for a flexibility estimation problem. Then then the algorithm will build or will set up the scenario, including which network to use and which flexibility service providers are there and how much they can offer. Then it samples the shifts from the flexibility service provider, and then it applies this Monte Carlo where it runs the power flows and it checks whether the power flows are feasible or not. And finally, it plots the flexibility area. So using this algorithm, we saw that the only difference between the power flow library, the library that will run the power flow, is only within this script. Therefore, we implemented the one function that runs power flows using Panda Power, and one function that runs power flows using the power grid model. First, assuming that the Panda Power was the ground truth, we compare them visually and also numerically to see whether the estimated flexibility areas are similar. And we saw that both libraries result to the exact same flexibility areas. But then if we start looking into the time needed towards running these simulations, we can see that, yeah, the power grid model is significantly faster and between 30 to 100 times faster than the one using the Panda Power network. So it reduces this computational burden issue by a lot. And yes, of course. Yeah, from my understanding, yes, that's if we have an idea why the power grid model is that much faster. Yeah, you can also maybe answer it. Yeah, from my understanding, yeah, it uses.
Yes. So the main reason that Power Grid model is much more faster than the Panda Power has to do with the implementation. Panda Power, they use a pure Python. It's a pure Python library with some number accelerations, and which have a lot of overhead when you doing array operations. But we use a C++ implementation, which are much more optimized.
And yeah, this was very helpful because using the power grid model, we can now test flexibility areas with much higher amount of service providers, but also cases where the optimal power flow methods will fail, such as for discrete variables. But yeah, then returning to the state-of-the-art methods in academia, I will now try to go a bit into the global limitations, or the limitations that both methods have, which is first that both the power flow based and the optimal power flow based approaches assume full observability of the distribution networks. So they assume that we know the topology and the state of the network before running these approaches, which is not the truth. And also that they apply simplified representations of the network, but also for the algorithms, they ignore transients that can be an issue. So in order to look more into that, we provided a generalized flexibility definition, which it's in our latest paper that will be that was accepted in the PowerTech. And for this generalized definition, we started viewing the problem through this block diagram, where the state of the network X shows the active and reactive power at each node of the network. U is the shift that can be offered by different flexibility service providers. But we also introduced this X tilde that shows that in real time, system operators only know a subset of the nodes, only can know the state for a few of the nodes. And also this information is noisy. And we say that the flexibility estimation algorithm should take this input first. We should recognize that this can only be the input and not the full network topology and operating condition before estimating the flexibility area. And also we recognized one more thing, that from each initial point to reach a different flexible point, there sometimes there is not only one combination of actions from the flexibility service providers, but multiple combinations of actions can happen. Therefore, the points covering this area should not belong to a set, but rather a multiset, which says that each point is aligned also with one integer value called the multiplicity, which is how many combinations can reach this point. Therefore, using these realizations, we provide the definition of flexibility between the time steps T0 and T1 as the multiset of all reachable points and their multiplicity, whose corresponding state in the network is an equilibrium point. So the network reached a steady state in which the system can converge after a disturbance or an action without breaching the network constraints. So after providing this definition, we also said that the objectives should not only be to recognize this area, how far it reaches, the range of this area, but also this multiplicity, which shows more or less how many actions are feasible and shows the confidence that the system operators can have in reaching different points, whether these points will be feasible or not. And yeah, to showcase this, we created a study case, which used the algorithm shown previously, where we assumed certain, using the Sigra medium voltage network, we assumed certain components to be observable, the ones in green. We assumed the flexibility service providers to be the same in all cases, the ones in pink. And then we assumed the rest of the components to be unobservable in real time. And we showed that if indeed this is the case, if we can only see these green components here, then the flexibility area, even if we have the same offers, can be significantly different without us knowing it. And yeah, this is shown because the observable components at most in these scenarios have 0.5% difference, but the convex hull area between these different scenarios can vary up to 42.7%. And the takeaway from these results is that if the network topology and state are completely known, then of course accurate flexibility area can be evaluated. But if this state and the topology are unknown, then the flexibility can be highly inaccurate. And the algorithms should be adopted to also include this limited observability component. And how this could improve the algorithms is that the algorithms could first, simply account for the level of observability and the uncertainty within the measurements. Also, representing the networks through equivalent models could help trying to inverse this X using another block here to try to reconstruct the initial X, all by enriching the network measurements and by applying PMUs or viewing in real time the state in different network nodes. So this is a bibliography for the figures I have used. And yeah, thank you for your attention. Do you have any questions? Yes.
If I understand correctly, you basically integrate over unknown components, unsearchable components. That seems to quite escalate quickly. If I understand correctly, is it due to the divergences between basically, for instance, reactants of a given user on, for instance, energy price or price of a kilowatt?
No. Oh, yes. They asked if the integration of all the network components is with regards to the reactive power. Sir, can you? Yeah.
Like literally to people reacting to
Oh.
costs, and therefore, let's say energy prices drop, they all of a sudden all crash onto using energy, and then the price increases again. And like, is it also related to those kind of divergences?
I see. The question was, whether this integration is with regards to the reactants from the people and with regards to the market prices and how they can respond. No, this integration or this higher derivative of the state is to also include the network transients, and to say that by applying power flow or optimal power flow approaches, we start ignoring that some network components, for example, might respond to some shifts automatically without explicitly being asked to shift their output. And this can change the active and reactive power at the point of common coupling.
Directly related to the fact that it's like not completely observable. Basically, literally measure missing information.
Yes, it's related to that. Yeah, and it increases the uncertainties and the errors that the estimation can have. Yes. Yeah, thank you for your question.
We have a question online.
Oh, yes.
Hello, Demetris.
Oh, hello.
Nice to meet you again. Very good presentation, first of all. And then my question is regarding the multiplicity graph you show where we have a cone in the figure. So what does this multiplicity means? That these point will occur for this many times? So what does this multiplicity mean in your graph?
In this graph, I think you're talking about this graph here.
Yeah.
So yes, this multiplicity is the result, saying that, for example, to reach this point here, maybe 100 combinations of flexibility shifts exist, and from all these 100 feasible combinations exist, which means that if the system operator would want to shift the operating conditions, or if the operating point at the point of coupling will be shifted to this location here, then there is a higher chance that it will be feasible, because there are much more options that they can use to reach that point. And also it shows, for example, that the points here at the borders of this area have very low multiplicity, which means that reaching these points can only happen with single or very limited combinations. And there is also high probability that reaching these points might be infeasible, since the combination might not be one of these feasible ones.
Okay, yeah, thank you.
Thank you very much for your question. Yes.
I have a question about the flexibility providers. Are they of the same type, so all of them can provide flexibility in the same way, or you consider differences in the type of flexibility and basically the type of response they can have?
In the current implementation, I just assume all of them to be the same. I mean, okay, loads, I assume that they can only reduce their output or increase it in very small percentage. And the distributed generation that can only reduce their output. But since we're simply sampling within a range that they can offer. They are viewed as the same. Well, very nice question. Thank you. So yeah, and yes, what kind of resources I use batteries or EV charging or buildings. So yes, in this algorithm, since I use networks implemented in libraries such as the secret medium voltage network, I just have the loads, wind turbines, and PV modules, or sometimes also synchronous generators. But I don't view into batteries or EV modules yet. But in the future, yeah, that will be an extension of it.
Do you also use it like your
in the algorithm, no, but there one of the options is to use optimal power flows. I don't use it, but yeah, so yeah, within literature, the for solvers, I think I'm not sure right now which exact solver they use, but with regards to how to combine the objectives, yeah, they mainly apply these three methods: weighted sum, constraint, yeah. Oh, I see. I see. Okay. Yes. Yes.
Maybe a more generic question. I was wondering how your experience model.
Oh, sorry.
How your experience was using the Power BI model in your research.
Oh, it was really nice and very helpful. Yeah, the documentation was very nice, and also yeah, Tony and the team was really helpful if I had questions, and yeah, it helped me to speed up my simulations quite a lot, and also in the future I might try to use models from Vision, and yeah, the Power Grid model will allow me to also use such models. Yeah.
Yeah, one more question for Tony. So are the high-grade low voltage and medium voltage network also available in the Power Grid model, or we have to build the network ourselves?
I think you're asking about Alliander network.
No, the high-grade low voltage and medium voltage network, are they already built in the library of Power Grid models, or one has to build in the model with given line and bus parameters ourselves?
I still don't use that Sigrid model. I'm not familiar with that.
Yeah, the Sigrid model Demetris used for Power Grid model simulation. So did he build the model himself, or was he able to use it from the library?
No, the library has a function that converges it automatically to the Power Grid.
I think you use the Panda Power example network, right?
Yes, I used the Panda Power and converted it to the.
Yeah. Okay, then I think that answers the question.
Yes. Yes.
Yeah. Okay. Thank you.
You have a question?
Yeah.
Yes.
It's also similar to my experience.
Oh, yes. What is the setup I use for these results? If I use multi-core or a server or somewhere? No, for these results, I just run it on this laptop. But also some delays that come with both algorithms are on the sampling part here, because this is the total duration it takes for the algorithm to run. So yeah, the data sampling is approximately the same delay for both algorithms, but the huge difference come for the power flows. Yes. Oh, yes, it was, yeah, really good. Yes.
About the estimated regions, which you showed with partially observable network.
Oh, yes.
And maybe you can comment a bit on what you noticed on basically what has more influence on better or worse estimating the flexibility, the feasible flexibility region.
Very good question. I think that. Oh yes. What is the main reason why, or the main affecting factor for these different flexibility area estimations between these different scenarios? I will say that the topology difference, for example, having a line being disconnected and not having it, not knowing it, could be quite a big difference. Yeah, because more or less the state differences or unobservable state differences are smaller. If we see here, are 8 to at most 20%, 19% difference. But when we have also like disconnected lines that we don't know, it makes the estimation quite wrong. Yeah. Thank you.
We have a question on that background. So, in light of this presentation, then these are three open source and possible for you to share the presentation.
Yes, of course, I will share the presentation. And yeah, so the algorithm shown here is open source, but without, so it was, this algorithm was also used for the publication in PowerTech, but it did not include yet. Oh, sorry. Yeah, I think, yeah.
No pipe, no battery.
Yeah.
Never help.
But it was not yet, sorry, yeah. The Power Grid model was not yet implemented when I submitted that paper. So yeah, we'll try to publish the new, to make the new implementation public, or the new functions public, so people can use it as well, and we can discuss with Tony how we can make that public. Yeah. Thank you. Yeah. Yes.
What kind of network parameters are being considered when you perform the power flow and stuff? That you don't have, the transformers be.
I think for your, so the question is from is what kind of considerations of the calculation argument is it used? Actually, maybe for damages, but the thing you mentioned about automatic temp changer, we don't have that function yet, so I don't. So I don't think damages you use automatic temp changer in your simulation.
No, I didn't use. Yeah, although it's something that can be used as source of flexibility, I didn't use it.
Which would be a very interesting discussion in the brainstorm session within an hour. So if this is much needed feature, we'll prioritize it. There are no questions more. I have a tricky question for you, actually. So we're very happy to see that the Power Grid model give you such a good performance benefit to your project. But if you are talking to PhD colleagues, in what situation would you actually advise your colleagues to use Panda Power instead of Power Grid model?
good question, but yeah, I'm not sure. I mean, of course, people got used to using Panda Power over the years, but in my case, the transitioning from the Panda Power to the Power Grid model was quite straightforward. So yeah, I will suggest using the Power Grid model. I didn't see differences. So yeah, in terms of computational speed, I don't see any reason. Yeah.
So the comments from Samson is that Power do give a very good visualization tool, which could be a benefit for many studies.
Yes, so I was having the same discussion as well morning with a graduate student, and I recommended her to use Power Grid model for the actual node flows and convert to Panda Power for the visualization and the administration.
That's very interesting to see. Irina?
I wanted to add to the discussion that something that Panda Power has the open source features and has support some graph searches on the network that are governed. So it can be done later before you need it, but yeah, it's something that Panda Power supports.
So also Irina mentioned that it's also about graph search and visualization. I'm looking at the Yap. Is Yap still here somehow? Oh, he's gone. Yes. Maybe let's have this kind of discussion later because it's very interesting. Oh, thank you, Demetris, for your presentation. We're going to a coffee break for half an hour and come back at 3 o'clock. I will also back to my laptop so yeah, let's have a short coffee break. For the people online, we will see each other again at 3 o'clock.
Again, sorry. I'm sorry. We wanted to Spanish. Was it easy to follow? Yeah, it was. It's surprising. Okay, because of the quite detailed. Yes, it was. So I'm
Francesca, you can already start sharing your screen.
Can you see my screen?
Yes, we can see your screen.
Okay, perfect.
So we will start again. Please, for the people in the room, please have a seat. Just had a very interesting presentation with Demetris about his PhD research, and now we have another interesting presentation about the industrial application of Power Grid model from Francesca from RSC Italy. So Francesca, the floor is yours.
Okay, good afternoon to everyone, and thank you, Tony, for your introduction. In this presentation, I'm going to talk to you about the integration of Power Grid model PowerFlow into the multi-energy semantic platform, and I've done this work with my colleagues Enea Bionda and Gabriele Paludetto. First, we have a short agenda of this presentation. We will have an introduction about the Energy System Research Institute, RSI in Italy, and then a focus on our lab, IoT and Big Data. Then I'll talk to you about the multi-energy semantic platform, which is a product that we are developing in these years. So platform aims and architecture, the main use cases, and then I'll focus on PowerFlow applications of networks in ISSIM format. Then the main theme of this work, which is the integration of Power Grid model PowerFlow into our platform. And this integration required the implementation of conversions from Power Grid model data model to ISSIM and from ISSIM to Power Grid model data model. Then the development of Power Grid model PowerFlow microservice, and then the main results that we have obtained. Okay, the Energy System Research Institute is a research company owned by the Italian government, and we are mainly involved in Italian and European research initiatives about to address the national energy, environmental, and economic goals. We are more than 300 researchers, and we have at disposal several labs and experimental facilities, mainly placed in Milan, in Italy, but also in Piacenza and Brugherio. In particular, we are part of the IoT and Big Data Lab, which has the aim of developing new innovative solutions in the field of big data, cloud, IoT, edge, and fog computing to support power system digitalization. In particular, with my team, we started with the study of smart grid applications. Then we included also district heating gas network application, and now we are going towards multi-energy. In this context, we are developing the multi-energy semantic platform, which is a semantic, modular, open source platform based on international standards to manage and study multi-energy networks. Here you can see the homepage of our platform with different sections for each energy sector. It is a semantic platform because it is based on the semantic model ISCSIM, which is the international standard to describe electrical components and their relationships. And it is a semantic model because it is a triple-based model, so with the subjects, predicates, and objects. And then to describe multi-energy networks, we have taken as reference this complete model for the electrical system, and we have developed ISCSIM dialects, for example, to describe district heating or gas networks. It is a modular platform because it is based on a microservice architecture, and it is open source because when it is possible, we prefer the use of open source solutions. It is the platform does not want to replace operator solutions, but it is an alternative that DSOs can consider to test new and innovative solutions, and it can be used, for example, also by students to test their applications. The central point of the platform is the interoperability. Because first we want to integrate data spread in different databases of a single operator, because usually operators tend to have a database to manage geographical information, another to manage customers' data, and another to manage assets, and we want to break data silos through the use of an international standard. Then we want to favor the exchange of information between different utilities, again through the use of a common model. And then we are going towards the integration of data related to different energy vectors, and also to support multi-energy applications. Here you can see a diagram block architecture of the platform, and so the platform is based on Kubernetes and the microservices and microservice technologies. We have knowledge graphs to describe the network's data, and then also a time series database. Another central point of the platform is the integration of semantic technologies and big data machine learning algorithms. Here you can see some of the use cases that we have considered with our platform. For example, semantic representation, asset and fault management, topological and geographical visualization. But here in this presentation, I want to focus on power flow of networks in ISCSIM format. So in the specific part of the platform dedicated to electrical grids, we can upload the different networks, and then we have at disposal different services such as power flow, optimal power flow, classes navigation, geography, and topology. And if we select power flow, we have different algorithms that we can choose, and we have both popular algorithms such as MatPower or PandaPower, but also new innovative algorithms. And this work that I'm presenting you at the aim to integrate power grid model power flow. Okay, the first step has been the implementation of conversions from power grid model data model to ISCSIM, and from ISCSIM to power grid model data model. First, from power grid model data model to ISCSIM. Why? Because we want to include in our platform power grid model networks, and also integrate power grid model fictional network generator, which is a functionality functionality in Power Grid Model library that it is very useful to have at disposal different test networks. And then from ISC-SIM to Power Grid Model data model, because we want to perform, of course, Power Grid Model Power Flow with ISC-SIM networks. So first, a short description of the two different models. Power Grid Model data model includes grid components for power system analysis. And here in the center of the slide, you can see the main components that are considered. So it is in JSON format. It includes both symmetrical and asymmetrical components. Well, here for this work, we have focused on symmetrical components, and I want also to stress that not all the elements are considered, just a portion of them. For example, we have not considered sensors or three-winding transformers, but just simple transformers. And then here on the right, you can see an example of model instance of Power Grid model. Instead, ISC-SIM is a very complete model to describe the electrical grids and under different points of view. And it is a semantic model, meaning that it is based on triples, subject, predicate, and object. We have considered the RDF XML serialization, and it is useful to describe for example, topology, geography, and asset of the network. Here in the center, you can see a portion of the model, of the components of the model that we have considered. Again, the conversion from ISC-SIM to Power Grid model considers just a portion of components. Okay, here in this slide, you can see a table where we have tried to find the correspondence between Power Grid model elements and ISC-SIM. For example, a node can be converted to a busbar section, a line to an ASCII segment, but it is important to note that it is not a one-to-one relationship, because in ISC-SIM, we have to also consider containment relationships. So a busbar section must be included in a substation, an ASCII segment must be included in a line, and then there are also elements to describe connectivity, for example, terminals or connectivity nodes, topological nodes, and so on. Okay, so the code is available as standalone beta code on this Power Grid model GitHub repository. Here I put the link, and so just using the main, you can activate the code, and there are also examples of input networks that you can test. Then the conversion is also implemented as a microservice in our multi-energy semantic platform as a Python microservice. And here you can see the front end of our platform with this import-export functionality. We can see a short demo about it because I've recorded this video. This is the home page of our platform, again with the different sections for different energy vectors. And then here on the left, you can access to different services, and among them there is also export from to ISC-SIM. Then accessing to this page, we can select the input model and the output model, and among them we have, of course, a Power Grid model JSON to ISC-SIM and different ISC-SIM versions. We can select one of them, and then we select a test case as input file. Here I will show you an example of power grid model fictional network with around 20 nodes and lines and so on. Okay, so once the file is chosen, you can run the transformation, and in few seconds you obtain your output. You output in ISCSIM, and here the network in RDF XML. Then it is possible also the other transformation from ISCSIM to a power grid model JSON, and the input file is selected. Okay, in ISCSIM version 17. And then in a few seconds we can download the result. Okay. Okay, so now we once the transformation is implemented, we can integrate the power grid model PowerFlow into the multi-energy semantic platform. So we can choose as PowerFlow type power grid model, and then there are all the parameters that must be set to run the PowerFlow. Again, we have a short demo. Here we go the smart grid section of the platform. We have different services at disposal: PowerFlow, optimal PowerFlow, classic navigation, geography visualization, and topological visualization. We select one of the networks and PowerFlow with this network. So here, power grid model fictional network. Okay, then there are different PowerFlow types at disposal. We can select the power grid model and then set the precision and the calculation method. And then we can run the PowerFlow. And we have the results for buses and branches. Okay. Finally, we have obtained some results using power grid model PowerFlow. So we have tested the power grid model with different input networks in ISCSIM with a number of topological nodes from around 100 to 1,400, and we have compared the results to PowerFlow, and we have obtained a 100x speed gain compared to MathPower with these input networks. Including model definition, so optimal results of power grid model PowerFlow. Then we have created fictional networks with a number of topological nodes from 1,000 to 20,000. And we have tested all the different power grid model algorithms. And again, we have obtained really optimal results in terms of execution times, which are always less than 0.05 seconds, while model definition requires less than 1.3 seconds. So to conclude, we have seen that we have implemented model conversions from power grid model data model to ISCSIM, and from ISCSIM to power grid model data model. And these conversions are available both as standalone codes on GitHub, and then as microservices integrated in our multi-energy semantic platform. And after the conversion from ISCSIM to power grid model, we could integrate power grid model PowerFlow into the multi-energy semantic platform. And we have compared with some test networks power grid model PowerFlow with MathPower PowerFlow, and we have obtained really optimal results of power grid model PowerFlow. A possible future next step could be the the use of power grid model asymmetric load flow calculation for low voltage network analysis, which we think that could be really an interesting application. Okay, thank you for your attention, and I'm glad to answer to some of your questions, or maybe you can just also write me if you have some doubts. I don't know.
Well, thanks, Francesca, for the presentation. So, any questions? Because of the receiver, please come forward. Yeah, okay, then I will repeat. So.
Yeah, thanks for your presentation. Interesting. I would like to ask a question about the microservice you use for power flow calculation. Do you use you calculate the multiple rounds of power flows? Are they mutually independent, or some power flows needs wait for other power flows?
Can you hear the question, Francesca?
Not very well, sorry.
So the question from Lei Wu is that when you run microservices with different power flows in a time series or any power flow calculations, are the multiple power flows independent of each other, or do you depend on your previous power flow to run your next power flow?
Well, are you referring to sorry? Mappa, are you referring to Panda Power with profiles? Or Math Power with profiles?
He doesn't mean specifically any power flow, just in general. Does the platform
as the power flow type, we have also Panda Power with profiles and Math Power with profiles. And in this case, the input for active and reactive powers are different, are considered at different timestamps, but the result at each timestamp is independent on the others. Yes.
Yes, Irina. So the question is regarding the ICSIM to power grid model conversion. Does it work for all types of networks, high voltage, medium voltage, low voltage?
Okay, so we have focused on medium voltage networks, and we have considered that, as I already said, a subset of elements, both for power grid model, data model, and for ICSIM. So if you have a look on the code on GitHub and you have some suggestions, or you want other elements to be converted, just you can suggest it. Yes, sure.
So also to give some context here, that we are working together with RTE on the SIM ICSIM to PGM conversions, and it is already as a beta version in our open source GitHub. So all of us can try to have a look and contribute or give suggestions or whatever. I see a question online from Eric. Please go ahead.
Hello. In your result metrics, you define an execution time and model definition time. What does it mean, the model definition? What is this metric?
Well, in Power Grid model, you have first to define your network from your input data, and we have seen that this model definition requires a certain time that is higher than the actual power flow run. So we have split the two different execution times to define a power grid model input network, and then to run the power flow.
But if you define once for one of the SIM network, for example, and if you change the parameters of the load or I don't know some switch positions, I think you don't need to redefine the network again. Am I correct? Or
Yes, but here the networks are different, so
okay,
every time, yes.
Thank you.
You're welcome.
Thank you, Eric.
Is the node taker topology as well as the bus branch topology, both of them implemented or not?
So the question is about the conversions of SIM to BGM. Is that a node breaker model or bus branch model topology?
Okay, well, in ISCSIM we consider a node breaker model, and we consider a node breaker model, and then we have a topological processor. We have okay, so a node is converted to a bus bar section, and also we consider breakers, and then we perform a topological processor to obtain topological nodes or their connections. Yes.
Okay. So the question is that when you do the conversion from SIM to BGM, do you also take into account that the status of this disconnect and switches, are they closed or open? Would that result in different input for power grid model?
Well, actually, we have not taken into account power grid model networks with switches, but for different works, we had as input also the switch status, and then we first converted the input network to ISCSIM, and then through the topological processor, we have taken into account the switch status to obtain our topological nodes and their connections. Sure. It could be a next step, maybe also to have as input in power grid model also the switch status. Thank you.
Any more questions also for online? If not, Francesca, can you go back one slide? Sorry, another one. So you have the comparison between a PGM object and a SIM object. I mean the one you have say which component is yes, this one. Thank you.
Okay.
I see that you map the SIM gen to energy consumer, which is a bit different than us. Aaron, I see you in the call because we are map actual generation to energy producer. So
okay, we have considered this first approximation, and with the considering generations, and with the P and Q with the opposite sign. I think it is, yes, an approximation, but it is a first step. Actually, in ISCSIM, we have all the classes to better describe generators with the synchronous machines and so on.
I see there is a online question about should the disconnector not be modeled as a switch? Akio, can you elaborate that a bit?
Yeah, thank you for the nice presentation. I was just wondering if the disconnector CGMES tag should not be modeled as a switch. I'm not pretty sure if link in power grid model is the same as a switch.
Well, in ISCSIM, we have different classes to model different types of switch. Switch is a general term. Then we have breakers, protected the switch, and so on. So we have still not focused on the specific class to model these connectors, but because they are not implemented in the transformation, so we can maybe talk together with Tony and find the better correspondence. Yes, sure. Thank you.
Thank you.
Any more questions? Thank you also, Aaron. My final question is to Aaron in the code. Can you comment on what would you find the differences between what we are doing at SIM conversions and the RSC are doing? I see you're in the call, Aaron. Oh, maybe he's away from keyboard. I don't know. Aaron, are you in the call?
Yeah, I'm trying to find my unmute knob, but my screen is a little bit messed up. Can you hear me?
Yes.
Yes. The question was the difference between SIM and
the difference of how RC is doing SIM modeling and what we are doing SIM modeling.
Oh, yeah. The biggest difference is that our modeling is based on JSON and traditional, the current implementation of SIM is XML. So there's a difference, but regarding the standard and the type of modeling, I don't believe there is a big difference. The other questions earlier regarding energy consumer, that's exactly what we are doing, Tony. We are don't modeling it as an energy producer, so we are still using the energy consumer.
All right, my bad. Thanks for your answer, Aaron. I would say thank you very much for your presentation, Francesca.
Thank you.
And now I think we can enter in the breakout sessions. So if I share my screen again, then this will be split into two. So for the people on site here, if you want to join the highlights and brainstorm discussions, please stay here. If you want to see a short demo or workshop for Power Query Jam, especially if you're new to Power Query model, we have a separate table there. So please follow my colleague Peter. And for the people online, if you want to join the highlights and brainstorm, also please stay in the call. Otherwise, there will be another call link posted in the chat, and then you also join another call for the demos. So let's spend 5 minutes to split the group. And for the people, I'm not going to use microphone later because the call is pretty near. So please, for the people staying in this room, please come forward into the front seat. Yeah. Guys, please come forward.
Wat hier in het midden zetten.
Wat zei je?
De microfoon die we hier in het midden zetten.
Ja. So I see also people decreasing online. I assume that's joined on the other call. Let's wait for another 5 minutes. Yeah, just quick pick some water. Very interesting. I thought that this room will be more people. Maybe we should switch place the other way around. People like the demo. I won't be using this because the speaker are also there. So if I'm using this, they will also get a. So I will put the microphone here. So for the people online, are you guys also ready? We are going to start now for the very short breakout sessions for to introduce about highlights of the past 2 quarters, and then we're going to enter a short demo, a brainstorm on what we are going to do. As we said, we are community driven, so we would like to hear what are the community want. Yes. So let's begin. So a bit more about the project governance of this project, and there's one thing which I will also introduce later is that we are now part of a Linux Foundation Energy. So legally and theoretically, this project Power model is not belonging to Alliander anymore. It's actually part of Linux Foundation Energy. We are, as Alliander, are currently the core maintainer and core contributors of this project, but that doesn't mean that it will stay there forever. And actually, the goal of Linux Foundation is actually to involve multiple parties. And if you look at current project governance, then you will see that it's now steered by 3 committee members. Jonas is here, I'm here, and my colleague Vienna is also in the committee member. And then with 4 maintainers at this moment. So Nitish, Wang, and Peter is in the other room for the demo, and Martin Hoffers. And then of course we have developers and contributors. But what do we do here? We usually do so-called community-driven development cycle. So we are not going to close the door and say, hey, maybe we like this nice feature, we like this nice, that will not work. We are listening to the community to see what is wanted from the community. So as some colleagues suggest about like a visualization, which could be a very interesting one. So if we can see about that. And then it's in a half-year cycle. So we have a meetup today. So today we are going to discuss what we want and from what the community wants. Sorry, and then we will break it into a half-year roadmap. So to see, of course, that work has to be prioritized between the request from Alliander or outside Alliander and so forth. And of course, during the development, we will continuously hear the feedback from the community to see what is nice, what would be nice, what can be improved, and blah blah blah. So that's more about development cycle. And then I would like to walk through what we have achieved in the past half year, Q1, Q2. So as I said, the first very interesting one is that we joined the Linux Foundation Energy. That's always the goal of Alliander open source strategy, as our director Rinke van der Rhee mentioned in the keynote speech. We also release our package now in Conda Forge, which I don't use Conda honestly, but I know a lot of people they do use that. So it could be a add-up. We have provided a CAV API, a Panda Power conversion, and then we have also some performance improvements for batch calculations due to some internal improvements. And then we have some feature improvements and bug fixes. And what's important to mention is that we are working very hard on the new functionality, which is a big epic, a short circuit calculation that's much wanted by many users, potential users. So we are trying to add it in our calculation call, which is ongoing. So stay tuned. The first one is now we are part of Linux Foundation Energy. This is a photo taken Thursday, yeah, right? Thursday, the first of June. So a very fresh photo. I was in Paris to present our model as a new project in the Linux Foundation, and then we also have a nice combination of audience and of that. Another highlights, some about the downloads per month. Also, in the past 4 months, average we reached like a 57K per month downloads of this package from PyPI. I have to have a disclaimer here. The reason, not all these downloads are downloaded by humans. So a lot of downloads we have, because many applications depends on us. So when they release a new version, and then the automatic pipeline will download our package to build their application to run their tests. So that all comes of downloads, but still 57K is a lot. We have also released in Conda 4. So for the people who are familiar with Conda, please raise your hands, please. Conda, also online. Are you guys familiar with Conda? So Conda is another package manager which not only meant for Python but also for other applications. And now you can do pip install, which is the official way of install Python packages. But for a lot of data scientists, if you're using Conda environment, now you can do Conda install means say Conda Forge Power BI model. So Conda Forge is a famous channel of hosting all the open source packages. Another highlight is the C API. So as far I think I can safely say almost all of you are using Power BI model through the Python interface. That is always the case. And in the last half year, we actually separated the C API and the Python API in a way that we can have our C++ core library, which is a header-only C++ library. It is wrapped in the C API as a dynamic library, and then it is further wrapped by C types as a Python API. So all the existing Python users, you don't actually feel anything. You just install it, use it. But the important step is that for other programmers or applications which are not in Python, but like in Java, C, C++, C#, R, or whatever, they can try to talk to Power BI model through C API. And we already see some leads to see some projects are not in Python but interested to using our project or model. Then this becomes now available. Previously, it's not. What is important now is that one, this is still experimental. So we are building a C API only. We never done that before, so we are not 100% sure which is a good C API. So it might change, maybe. And the otherwise, next step is that once we do have a good stable API, we have the ambition to actually publish it to also famous C++ package managers. We hope in one day you can do apt install Power BI model or brew install or Conda also Conda install, but then for the C part of the library. But then that's our ambitions. Another one is the Panda Power conversion. I think Demetris, you already benefit from it. So we have a Panda Power conversions in our Power BI model IO. What you can do, you can do a round trip. So if you have a Panda Power input, you can then run the conversion to convert it to PGM input. You can run the Power Flow, then you get a PGM output. Then you run another conversion to convert it to Panda Power output. This will achieve the same result as if you run the Panda Power flow functions from Panda Power input to Panda Power output directly. You should receive the same results. It's already online official, and I see already nice users which benefits from this function. What we also have worked on is to integrate these conversions to the Panda Power code base itself. So we hope that if you're a user, you actually have a Panda Power network, you can run a function called run_pp_pgm, and then inside Panda Power, it do the steps I just mentioned here. So it calls the input conversion, it calculates Power Flow, it calls the output conversion, and then you have the result in Panda Power format. In this case, we hope that user can migrate from Panda Power to using our model just by simply switching the code of the function call. Is pp.runpp, change it to pp.run pp_pgm. It is merged this just before this. So after the launch, it is merged. So I'm very happy to show the result here. So you see merged. If 3 hours ago you see here. So it's actually merged now. But then it is now in the developed branch of Panda Power. They don't have a rolling release type, so they have a fixed release window. So if you can wait a bit, then you can wait until Panda Power release the next version of Panda Power. Or if you really are eager to try it, you can install is from source. If you install from the GitHub using pip install. The question is, do I know when they will be planned for next release? The answer is no. But let's ask Norman later about how things plays out. Yeah. So, any questions so far for the highlights for Q1, Q2? Yes. So the question is whether it will be the option to run batch calculations using Panda Power. We are working on that, but we are also hesitating on that. Also, we see if the user pattern of perspective, like what you did, is that you convert the input data, but then you provide the batch data separately directly to Power Query model. So we are hesitating whether that will be add a lot of value to the user or not. So that's the part we are hesitating. So depends on what will come up. So we will soon have the brainstorm. So if this is important to you, also to the people online, please put a note in the board. Yes.
Do you have any idea how many other institutions are using Aggregated? So any other DSOs?
We have now a pilot project finished with Stadium and Annexes. So the other two big DSOs from Netherlands. We hope, so that's a very big hope, that we hope that at the end of the year, so the next half-year development cycle, we can invite them to give a presentation. More questions also from online? If not, then I would like to go to also a very interesting one. As I said, we are community driven, so we like to see what kind of decision, when we make decisions, we want to see what kind of preference from the community is. Actually, we have two proposals, pending proposals to see. We would like to ask your opinion on that. The first one is that the supported Python versions, currently we are supporting Python 3.7 onwards. As you know, Python 3.7 itself is now end of life. So we would like to drop it so we can support from Python 3.8. Think about that later in the Mural board. In the board, you can vote if you like this decision proposal or not. Another decisions we would like to take together with the community is supported the Linux distributions. As I say, Linux is a very open world. Everybody can build their own Linux distribution. On one side, it's really good. On the other side, it makes binary compatibility also an issue. Python Package Authority, they use a so-called many Linux group, which actually said when you build a package, you specify what kind of subset of Linux distributions you want to support. In this way, you can guarantee that you will build something that at least works with some of the Linux distributions, not all of them. And what our current many Linux tag is many Linux 2014, or another alias is many Linux 2.17. This will support. This is not an exhaustive list, by the way. So it will support CentOS 7, Ubuntu 13.04, and Debian newer than 8. Our proposal is to move it to many Linux 2.28, which will. So that means CentOS 7 support will be dropped, and anything Ubuntu, anything earlier than 18.10 will be dropped, and also for Debian earlier than version 10 will be dropped. Is that an issue or not? Please express your opinion later in the Mural board, so you can say if this will be an issue or not. If you're a PhD or something, you're working with the latest Ubuntu Linux, that's not a problem. But for some people, they deploy their product in the production, they might want a specific Linux distribution. So please share your thought here. And also, because this session is recorded, so some colleagues will look at it after. So this is one of the main part you should look at. For the people who are looking at the recording afterwards, please also express your thought later. There is a link here. If we go to the link here, then we see the complete list of which tag. So we are now 2.17, which support this kind of Linux. Everything newer than this is supported. we are moving to here. So everything above will not be supported anymore. Done. Is that the issue or not? That's the reason we want to bring this up, because the Ubuntu 18.04 is just end of life. So we think it might be a moment to drop this support. And the reason we want to do that is because once we move to this, we can benefit from more advanced C++ compilers from GCC and Clang, which will on one side implement new standard, and on the other side give more performance optimizations. Yes. Yes. Amazon, Brian, can you elaborate yourself?
Yeah. Some of the IDEs we use at Alliander, like integrated IDEs in the cloud, are based on Amazon Linux 2, I think. So I'm not sure if the update is.
It is indeed. It is earlier than 2.28. So if yes, you are correct. If we drop that, this will not be supported anymore.
But I'm not 100% sure. But I think
you're not 100%
somewhat.
if Amazon Linux 2 is used. Can you also type this concern later in the mural board so we can note it down?
Yeah, sure.
Yeah. Thank you. Any more questions?
What about different LIVC distros?
Stefan, can you elaborate yourself?
Well, many you show are actually standard libc variants, but you have, for instance, for Docker containers, Alpine that actually uses a different libc linkage, and you do not even provide a binary or a build for it. So that could be a problem to deploy smaller Docker containers, because Debian and Ubuntu shouldn't even be on the list because it's actually Debian, but it's my opinion. Alpine is always a lot smaller, therefore less issues with deployments and going to deployment. But because it isn't basically supported, you can't run it.
Thank you for your question, Stefan. I think the question is about supporting other C library runtime than glibc. And as far as I know, Alpine uses the muzzle implementation of the libc, which is also a very compact and modern runtime. The question, the short answer is that no, you are right. We don't provide binary packages for a muzzle-based Linux. We do have plan to do so if NumPy provides it. So we actually follow the NumPy steps here, because we are dependent on NumPy. So if NumPy doesn't provide a binary package for muzzle, it doesn't make sense for us to provide a binary package for them, because the user has to build from NumPy from source anyway. Is that the answer? Is this the answer for you?
Yeah, but that leads me directly to a newer question, but I wouldn't ask it.
So this is the question you are. So upload all is, are they actually closed? So build views. So this one, I'm not going to search it now, but I do know that NumPy at this moment they do not have muzzle Linux yet. We are waiting for them to provide it.
And that's okay.
Yeah. More questions? But again, this is only about binary distribution. You can, or the user always has the possibility to download the source code and build it from source. Usually that's pretty easy for Linux. If not, then we will go to our next step, which is our mural. So we will spend like a 15 minutes time to actually brainstorm on the idea about what you want to have here. So Nitish is now posting the links to the mural board. So for the people online, you can already directly open the link and then put your thoughts on it. For the people here, you can also open your laptop and then put your link here. So this is the mural board. So there are 4 categories. So you can put what kind of what kind of functionalities you want to add, either to Power System functionalities or to the software API or the data conversion or others. There are already some sticky notes there, and that's mainly for the the request from the last time, so half a year ago. So if you still like it, you can just put a thumbs up. So there are thumbs up there. You can copy the thumbs up and put in the existing sticky notes, so people knows that you want that. And do not forget, in the left side, you will have the community discussion of this report. So if you're okay with the new proposal, please put a thumbs up. If you're not okay, please put a thumbs down. And from Brown teamers, please also put a special note there about your Amazon Linux concern. Let's spend like 15 minutes for this. So before you make 2 new sticky notes, please have a look if your wishes already involve the existing one, then you just have to put a thumbs up. Do we need more time? Oh, I see some people still working, so let's wait a bit. Are you guys finished? Yeah. Also, people online. Then maybe let's first look at the two communities decisions we just presented. So I see no objections to job 3 Python 3.7 support, so that's a good thing. We're going to do that. For Linux support, that's of course the question about Amazon Linux version 2, which is only supported to 2.26, which could be an issue. Let's one, Timus, right? I will talk to you later about how can we summarize this issue. About the tickets or the sums up you put, does anyone want to elaborate what your request is? Also for the people online. If not, then I will zoom in a bit to see if I can understand everything. Oh, again, the automatic type changer is one of the much needed features. So I hope we can do it within the next half year. We have put the Apache Arrow ticket here. Can those who put the Apache Arrow, can you elaborate a bit?
Me?
You?
So yeah, so basically in our project we use a lot of Arrow Python libraries with an Arrow backend. And I know that the PowerGrid model is based on NumPy, if I'm correct. And I think for like a memory optimization for us could be that we have some support for conversions between Arrow formats and NumPy formats in PowerGrid model. I think there's a discussion also which goes a little more in depth in the PowerGrid model organization.
Yeah, I actually see that. Okay. Let us see. Do we see any more? Include switch in for measurement field when converting. Irina?
Yeah. Yeah, because this information, for example, with the vision to target model conversion is not there. So then we have to kind of keep it somewhere else for it and map things when using measurements and assigning them to, for example, sensors target model. So it would be nice if we can also understand that it's not necessary per se for the power flow. Yeah, nice to have.
Thank you. So the comments from Irina is that is during the conversion of vision, right? That's specifically on vision. You want to also include the which switch are connected to which side of the line or cable or transformer, right? Okay, thank you. Okay, this is very interesting. We see actually a lot of new stuff here. Visualization is already something mentioned, so I'm glad that this is also put here. Documentations and how case studies, how PGM is used. Another ticket from Irina, access intermediate data.
Yes, so it's related to the data while detecting bad measurements. And I think, well, I haven't looked into it, but I don't know if it's possible to extract like the matrices that are used in state destination, but they can be used for, yeah, for this purpose basically. So that's why I brought it up, but I also don't know if, when are we going to look at it necessary. There.
Thank you. So the request from Irina is that to be able to access intermediate data on the matrices. I think this also some requests also coming from the power flow calculations, and then with similar requests like in here, right? Access intermediate incidence matrix or Y matrix or Jacobian, which on one side is very interesting, on the other side is quite challenging. That's actually, to be honest, the benefit of C++ performance, but the drawback is very hard to expose internal data structure to outside world. Not as easy as Python. Then you can just go to the Panda Power source code and then somewhere, even in the live debug, you can put a breakpoint there and then save the data, which for PGM is pretty interesting. But I think for this one, we can have a separate session to discuss with people who are interested. So, does the people online, does some of you want to elaborate what the stuff you put on the board? If not, then let's wait until the closing. So let's wait until the other part of the session come back to here. Then we will do a closing, and then I see the drinks are already prepared. So let's do a quick closing. They are here. I see the drinks are already prepared, and the guy actually asked me when they can serve the snacks. Of course, I said as soon as possible. So let's have a seat, and then we have a very short closing. Can the people online hear us? I see less people joining them before. Maybe someone lost in the call. I don't know. But let's continue here. So yeah, we are almost the end of this meetup. I'm very pleased that all of you can come. Of course, our goal, as we said before, is a community-driven ecosystem. That means we are developers, users, stakeholders. We work together to provide a better tooling for the energy sector community. So we should benefit from not only the DSOs, the universities, but also we hopefully bring this benefit to the commercial parties so they can actually make a good business model based on this project. Think big. So we have this kind of meetup. Of course, our long-term goal is to have like working groups, hackathons, brainstorms, tutorials, workshops, consultancies. These all everything is we're open for every kinds of collaborations. So if you have any thoughts, ideas, just contact us. Send email to me or to my colleague Jonas or anybody in the loop. Or if you have something, just let us know. We can always think about how we can do it nicely. Some about communication. So sometimes we get the question, how can we communicate with the project? Of course, one important one is the mailing list. So afterwards, actually we'll send also the link to the mailing list. It's very important you actually subscribe to the mailing list, and then we will regularly publish either new release notes to the mailing list, also like this kind of event, or when we have a hackathon or brainstorm, we will publish through the mailing list so everybody knows that we have a new event. A tricky part is that apparently elephantEnergy.org is not a famous domain name. Sometimes the mail ends up in the junk, which is unfortunate. So I please also check the junk email. And I think Jonas and I, we are also working on for important our strategic partners. We're working on with the IT department to whitelist this domain. So, roadmap. So that's also one thing is that we publish our stuff in the roadmap here, which is here. The nice roadmap. We have something like Q1, Q2, Q3, Q4, and then you can also see there are different views of the roadmap. But then I just published the things here. And then for if you have new ideas, there's usually two ways to do it. So if you have a rough idea you want to discuss with people, then it's better that you go to our discussion board. So that's like the question raised about the arrow adoption is already there. So if you have a rough idea you want to discuss what would be possible, what is needed, you just post a new thread in the discussion board. If you already have a concrete idea, I just want this feature in a particular library like Power Query model, then you can just directly go to one of the repositories. Like say, I want to have a new feature in Power Query model, the calculation code, you just go to the issue with a new issue, just like what you do for any open source project. Then you say, I want to report a bug or I want to request a feature. So simple as this. Last but not least is, of course, I get people asking, how do I contribute? It is very important to emphasize that we do not, let's say, not only the contributing to code is a contribution. We see different ways of contributions. And look at here, we have this kind of circle. If you're using the library, you want to give feedback to the, hey, this is nice. You want to give feedback, report bugs. That's already a very huge contribution to us. And of course, we are a physical model. We need validation cases. If you want to produce new validation test cases, if in your application you run something which produces not a crazy result, then you might want to create another validation test case so we can look at it, how this is possible. That's another contribution. Of course, if you're willing with you would like to program in Python, then you can always try to see how can you improve Python API. And for the C++ hardcore programmer, it is all responsibility to contribute to the core like calculation code with new algorithms and models. We also try to figure out what kind of issues in the board are friendly for the beginners, for the first-time contributors. So if we go back to the roadmap here, there is a real called first good issues. It's actually the ticket with the label good first issue, and then this theoretically should be friendly for the first-time contributor to look at it and to say, hey, if you want to do something, maybe this is the way you can look at.
Also notice the expertise.
Yes.
For instance, if it's marked C++ and you're really shy of doing any hardcore programming, then possibly those are not the best issues for you.
Yeah. So the addition of Matan is that we also here we listed what kind of expertise are needed to complete a certain issue, and then depends on what your background is, you can see about what kind of ticket you want to pick it up. So that's reaching the end of the meetup. Any questions? Are there questions online? Yes.
When will be the next meetup?
We try to do it. So the question is, when will be the next meetup? We try to do it in a half-year cycle. So I hope to see you guys again in December. And again, maybe that's also something to emphasize. The meetup doesn't have to be here. That we are community driven. So if your organization thinks, hey, I have a nice demo to show, and you want to invite a lot of colleagues from your organization to join, you might want to think about host a meetup at another location, maybe until Delft. Thank you. If not, I think the drinks are ready. I would like to thank you all for joining, and I hope that we can have a nice development in the coming half year, and see you guys back in December somewhere. Also for the people online, thanks for joining, and let's have a drink for the on-site people.